Hello everyone. This is actually a video I've been planning for quite a long time actually, and the idea of this video is to bridge the gap between the advanced stuff I'm planning and that requires a strong foundation. Okay, so this first one is about classes and object-oriented programming mostly. Okay, so there are a few caveats. Number one is I'm gonna, skip on the bookish or the way they teach in universities and colleges. Big words like polymorphism, smart, the big four, etc. Because I'm self-learned and I have this perspective about these things that uh, you don't need to understand these things to code better. You need to learn to code better, and these things will come naturally to you. Okay, so you will get them. Okay, so I will be explaining these things, but in my own words, and you will get them, and then you can read the theory all you want. Okay, so this is going to be a video where I will be using analogies a lot. If you remember my state machine video, I used the word cartridge a lot, which was my way of conceptualizing things. Same will happen here. And second part of this video is going to be, code. And this is going to be a really short video, covering a lot of concepts, and I think you're going to like it. Now, number one thing I want to cover is classes versus instances, and how to conceptualize them. Okay, so the analogy I use in my head is classes are recipes. Okay, now imagine a paper with instructions on how to make an omelet. Okay, so that paper is the recipe, it cannot be eaten. That paper is not an actual object. The paper is telling you how to create an omelet, and it's explaining to you what an omelet is. But the recipe itself is not an omelet. Okay, so that's how you have to think about classes. Okay, when the object-oriented programming, when you talk about OOP, you're not talking about classes. You're talking about the objects that you're going to be using for which you wrote the recipes for. Okay, so let's say that recipe is used to create instances of omelets. Okay, so when you say new omelet, that's an object being created. That's an object that is the one that will actually have all the things you were talking about when you were writing the recipe. So when you're coding, when you're saying public, class, XYZ, you're actually writing a recipe for an object that will be created using that recipe. Okay, so try to conceptualize it like that. Okay, now next, what we're gonna do is we're gonna further dig deep and try to envelop all the concepts in that analogy. What does that mean for fields? Okay, so private variables and fields are the recipe's way of saying each of the objects I create can have their own set of these values. So in other words, if we say int salt, then each omelet we're going to create can have a different value of salt. So one omelet can have more salt than the other one. Okay. Now another thing is, like, if you make that variable or field public, so technically what you're saying is that an instance of omelet that has already been produced, you can still change this value on it. So in other words, you can change the amount of salt on an already produced omelet. Okay, now this is the interesting bit, the static variable. Okay, so this is a lot of this creates a lot of confusion when people are trying to conceptualize stuff, and that's where they get confused and start thinking of classes as kind of objects. Now, this is my way of explaining this. Now, imagine the static variables and fields is the information that you write on the recipe, not the omelette. So in other words, if you have a paper in your hand that is telling you how to create an omelette, then if you want to write a certain bit of information on the paper and not on the omelette, then you're going to make that variable static. So that information could be every time I make an omelette, I record certain information about that omelette. Or let's say I store a reference to that omelette. Or let's say I have a counter going telling me how many omelettes I've made so far. So that kind of information can be written on the cookbook or the paper. Okay, so that's where the static variables and fields come in. Okay, but they're like 5% of the magic. The real interesting stuff is in the instance variables. Okay, now what does that mean for methods and functions? Now, functions are a recipe's way of saying the objects created will have this functionality. Okay, so this is a method, this is a function, this is a call, this is something you can do on the objects that I will create. Okay, so when you're writing a method or a function in a recipe or a class, what you're saying is that once an omelet has been created, then you will be able to do this on that omelet. Not me. You cannot call an instance method on the recipe. You cannot tell the paper to get eaten, okay? Or increase the salt on the paper or the cookbook. No. You're supposed to increase salt or eat the omelette, not the paper. Okay, so let's say each omelette has a method called get eaten. So if you want to do or make a call to that get eaten method, you're going to require a reference to an instance. That is technically what you're saying is, dude, which omelette I'm going to eat. So without knowing which omelette you're talking to, you cannot call these methods. So you have to have reference to an instance, or in other words, according to our analogy, an actual omelette before you can eat it. So that's why we have to put our references in a variable before we can actually eat them. When we say my omelette dot get eaten, we're saying whichever omelette is stored in my omelette, I want to eat that one. Okay? We're not eating all the omelettes, we're not eating the recipe. We're eating that omelette that was created using that recipe. Okay, now then static fields and methods. Okay, so that is the same counterpart to that fields thing. What the static methods are basically functionality that the cookbook is providing or the paper is providing. So, in other words, you have a certain set of information that, if you remember, the cook has been, let's say, writing on the paper. If you want to do certain kind of functionality on that information or on the paper, let's say the cook wants to know, hey, how many omelettes I made today which had no salt in them. That kind of functionality should be static. Why? Because that functionality does not require a specific instance of an omelette. Okay, so you're not talking to one omelette and asking him, "Hey, how many omelettes have no salt in them?" And that omelette will be like, "I have no idea, man. I only know how much salt I have. I have no idea what the others have." So this method will be static method. That's why you will be able to call it by omelette dot, let's say, list of omelettes. So that method did not ask you for a reference. It just ran on the name of the class because that method actually is part of the paper, the cookbook. Okay, let's keep moving. What's the big deal about OOP anyways, right? So this, from here, it's going to start getting very, fun and interesting. Why? Because these are certain things a lot of people don't realize are bread and butter of object-oriented programming, and that's what they make this kind of programming fun. Now, number one, a recipe can say, hey, make an omelet like that other recipe, but let's do only these few things a little bit differently. And you saved a massive amount of time. Okay, so you can say, hey, make an omelet like the omelet recipe tells you to, but do these things differently, and then you'll have an omelette du fromage and not just any other omelette. You said new omelette du fromage, and that script or that recipe inherited from omelette. You did a few certain changes in your recipe. The other instructions all came from the omelette. Number one advantage, you saved a lot of time. Number two advantage, let's discuss it through another example. Let's say you have a recipe called dog and you have a recipe called cat. Very common examples used mostly, but I'm going to be using them quite more interestingly, I suppose. Anyways, dog and the cat recipes both inherit from living thing recipe. Okay, now, and a really interesting thing, again, a lot of people don't realize they can do it this way, is objects created from recipes that inherit from other recipes can do some really powerful things. Number one, let's say you wanted to make a method call to living things, okay? And that list actually can contain cats and dogs, because obviously cats and dogs are living things. That's why we say inheritance is a relationship. A cat is a dog. Okay, so a list of living things can contain references to cats and dogs, but a list of cats cannot contain references of living things, because a living thing is not necessarily a cat. Okay, so if you have a list of living things and you say, you call speak on all those living things, right? And now the interesting thing is the cats would meow, the dogs would bark. But to you, you were talking to them as living things. You had a list of living things and you said living things dot speak, and all of them did their own thing. How did they know to do that? Because the object itself knows that it's a dog. Although it's stored in a list of living things, the dog knows that it's a dog. And as I said, when it was being created, certain functionality was modified. So we said speak, the dog knew that his version of speak is barking. Okay? Another example to understand this is, let's suppose you in your game and a grenade explodes and it wants to do damage to everything within a certain range. Now, um, imagine that grenade's code looking like this. Hey, all tables break apart, all cats start bleeding, all dogs run away, all beds catch fire. That would be a really tedious code. We don't want to do that. What we want to do is the grenade only needs to say, hey, anything that can get damaged in this range, take damage. And they will do their own thing. Now, the table will break apart, the cat will start bleeding, the dog will run away, because they know it's up to them to do whatever they want to do when they take damage. It's not the grenade's job to tell them what to do if they take damage. The grenade's job is to just tell them to take damage as entities. Okay, so let's suppose all of these things inherit from entity, then the entity recipe will have code or a method called take damage, and all the other things will be inheriting from entity, and then they will be overriding uh, the virtual method called take damage that was in the entity script. Okay, I'll get more into that detail, and plus obviously I'll be coding, so you'll watch it in action. Now, What does that mean for you? Now, the most important thing in object-oriented programming you need to remember is if you're not playing with the information in your game or in your code, that information is playing with you. And you don't want that because very soon that information is going to get out of hand. It's going to become tedious. You'll have no idea where what is, and it's going to become spaghetti. And that is exactly the point of coding like a mannered person. So you don't want that. You want to be in control of the information, not the other way around. So let's practice. Now I wrote a few things on the fly to like practice that kind of conceptualization. So question number one, you want to do some kind of operation on all living things that are alive. Okay? Now, where would that information be? Okay, now you want a list of all living things that are alive. Where should that information logically be? The correct answer and the most convenient way is a static list of living things in the living thing recipe. Okay, although, as I previously explained, that living things list obviously contains in itself dogs and cats, but we don't give a shit. We want all living things, including dogs and cats. Okay, then let's imagine we want to kill all living things. We want to call a method that makes all living things die. Okay, but when a cat dies, it says, what the when dog dies, it says thanks for all the dog food. Okay, so they do different things when die is called. So what's the best place for that method to be? And the correct answer is in living things recipe, there should be a virtual method called die, and the cat and dog would have overridden versions of die. Okay, so we will say all living things die, but they will do their own thing because they have overridden versions of die. Okay, because they know they're cats and dogs. We only give a shit that they're living things. Next, grenade example. A grenade wants to kill all things in range. It will look for all living things, not all dogs and all cats. It will just look for living things and tell them to die. Okay, now this is also another very interesting thing a lot of people don't realize they can do is when you create a dog which inherits from living thing, the constructor of the living thing also gets run. Because in creating a dog, technically you're also creating a living thing. So the living things constructor will get run. Unless, let me explain. Let's suppose you have a dog and when it gets born, it requires no information, right? So you will obviously create an empty constructor or no constructor or whatever. The living things constructor is going to get run. But imagine you required some kind of information in the constructor. That's when things get tricky for a lot of people, but they shouldn't. That's how you do it. Now, imagine all living things have a value or a float called maximum health. Okay, so in other words, a dog could have more maximum health than a cat. In other words, it's stronger. Let's say a dog has a maximum health of 120. Now, that float exists and should exist in living things because in our abstraction, we are saying all living things have maximum health and all living things can die and all living things can take damage. So, our living things will have all the code related to managing health and dying and healing and stuff. Okay, so when we create a new dog, that maximum health is a requirement in the constructor of living thing. Okay, and obviously then you will be forced to create that requirement in the constructor of the dog as well. So you cannot say new dog bracket open bracket close. No, you will have to say new dog bracket open 120 bracket closed. Now comes another important point. Do you make a new variable called maximum health in the dog recipe? Should you? depends. And what that depends on is, in our example, we shouldn't. Why? Because if we create a maximum health variable with the exact same name as the one in the living things recipe, which we are inheriting from, the dog recipe's maximum health variable is going to hide the maximum health variable in the living thing class. In other words, we'll end up with two fields, one maximum health in the dog class, one maximum health in the living thing class. Plus, our code won't be happy till we meet the requirement of our living thing constructor anyways. So what we're going to do is, and what we should do is, because all of our code that manages health exists in the living thing class, why the hell should the dog class have a duplicate of all that code? We shouldn't do that. What we simply should do is forward that information to the constructor of the living thing class and do our own dog things, man. The living thing is handling maximum health and it has a maximum health variable. The dog class should not have a maximum health variable. What it should do is ask for maximum health in the constructor and then simply pass it along to its parent constructor. And yes, you can do that. I'll teach you how to do that in the uh, code. Okay, so let's do this in code and let's actually, practice all these things and see the magic in action. Hope you like this part. Thank you for watching.